Welcome to solverfy.
So in this problem, we are told that we weld two steel plates here and here to an I-beam here, and we want to make sure that the area moments about the centroidal axes of this whole section are equal to each other, so that it essentially has the same bending rigidity in both about this axis. So if we try to bend it this way or we try to bend it this way, it'll have the same strength. We're told that the plates are 26 inches long and have a thickness of 1 inch. We're given the type of I-beam we have here. And so then we know what we need to find is we want to find how far from the center of the plates we should weld the center of the I-beam so that the two area moments are equal. Here's the area of this I-beam. We can look it up. Now we want the area moments about the centroidal x and y axes to be the same. We know I set up a coordinate system here at the center of the I-beam, and so because of symmetry we know that y bar is 0, so this axis and this axis are going to be the same because the centroid in the y direction is going to be right at the middle of these two things. And we know that we can find the centroid in the x direction, so this distance here. So that is the total area of this whole section times this distance. And since the centroid, I've set up this x coordinate on the centroid of the I-beam, we don't have a contribution in there because x bar 1 is 0. And so we have twice the area of the plates times the distance from this coordinate to its centroid, and that is a. So we find out that x bar is 2a2 all over a times a. Okay. So we can look up the area moments for the W section here, and about these axes, its centroidal axes. In the x direction, it's 385 inches to the fourth, and again that's going to be the same as about this axis. So we got that one. No need to use the parallel axis theorem for that. And then about the y-axis, about this y-axis, it is 26.7 inches to the fourth. Now the total, or for the plates, or for the y, we need to shift it. Okay, so here we need to get the area moment about this y-axis, we need to use the parallel axis theorem, and we get that it's this value about the centroid here, and then we need this length here, which is x bar squared. Okay? So we can find that in terms of a at least. Now for the plates, we have their centroidal area moment properties. And again, we need to shift things. So for each plate, we need to shift by an amount, by this amount here, because the centroid of the plate is here, and that's and we need to shift over to here, and this distance here is a minus x bar. So we have this shift. And we know x bar in terms of a, so we can substitute that in, and so now we have iy2 as a function of a. Likewise, we can figure out about the centroidal x-axis, and so in that case we have we have to shift by this value, and that is this distance here. Okay, so this distance over 2 plus the thickness over 2. Okay, so we get this here. Now, the total area moment about the centroidal x-axis is just the sum of all the pieces, and we want to make sure that that is the same as the total area about the y-axis, which is the sum of those pieces. And what we get is that this value here, we plug it in, is 3,353 inches to the fourth. And the y one depends on a, and so that is 2,956 plus 9.22a squared inches to the fourth. And setting this equal to this, we can solve for a, and we get that it is 6.57 inches. So we need to take this and probably, so 6.57, 6.5 is actually at the quarter point. So just a little over the quarter point we need to weld this I-beam.